Hello, algebra students. Mr. Lawrence here, and we're going to do a quick video here on sets, subsets, and complements. And remember, a compliment is not "you are so good looking." No, that's not the kind of compliment we're talking about. All right, let's just take a look at some subsets here. All right, here I have a set. U is the universal set. Now I'm going to pick a subset. Okay, I can pick any subset I want of this set. So I'm going to call it set A. It's going to be my subset. And I'm going to pick the set of dog, and cat, and then fish. That's going to be my subset, right? Okay, so that's the set of A. Whoa, what the hookah waka is that? Let me get rid of that little thing there. Okay, you think making braces is challenging with a pencil? Try it with an airliner. Lots of crazy business. All right, the complement of set A, denoted like this, A prime, it's called the complement of A, is the set that completes A. Why is A incomplete? Because it doesn't make up the entire set of U. U is the universal set. It includes dog, cat, fish, bird. A includes dog, cat, and fish. Left out the bird, didn't it? Yeah, well, let's put the bird here, and now we have the complement of A. The complement completes the subset. So if you put A and A prime together, you get the universal set. So it's a pretty simple idea. Okay, we got to make sure we know how to do this. All right, so I've got one for you to try here. I've got U is the prime numbers less than 12. All right, the prime number is less than 12. I want you to, first of all, give me the roster notation for U. Then I want you to pick any subset of U, write it down in set notation, and then find me the complement of the subset that you picked. All right, go ahead and pause the video and do that. All right, if you haven't done it yet, you should pause the video and do it. Otherwise, you're just wasting your time and mine. So I am going to first list the roster notation of U. So the prime numbers, the smallest prime number is 2, and then 3, and then 5, and 7, 9, 10, 11 is a prime number. There we go. There are all the prime numbers less than 12. All right, I'm going to make my set A, my subset, I'm going to make it the set of 2 and 3. Okay, you could have picked anything. Now, I would recommend to not pick the empty set or the entire set because it gets kind of weird. When you go to do the complement, you can do it, but it's strange. All right, the complement of A is going to be what's left over from the universal set. So I picked 2 and 3. Well, that means the complement of A is 5, 7, and 11. And there you go. That's all a complement is. Very simple idea. Okay, there's one more for you to try this time. I want you to pick a subset that has at least 4 members. Okay, go ahead and pause the video, do that, find the complement. Okay, here's the one I'm going to do. Again, if you haven't done it yet, please stop the video and do it. I'm going to pick the subset of 6, 8, 10, and 12. Then I'm going to pick the complement of A. The complement of A is going to be what's left over. Will just simply be 2, 4, the set of 2, 4. And there you go. That's it. Okay, now I'm not quite done with the video. I want to talk about how many subsets there are because we've done this in class. We did a little formula, but some of you either didn't master it or don't remember it or just didn't pay attention to it. I don't know, but it is very important. It makes our life easier. So I'm going to list the subsets of these different sets and see if I can figure out a formula to tell me how many subsets a set will have. So here we go. I'm going to do the subsets of A. A is the set of Jim, and I'm going to get lazy. I'm just going to use J for Jim. Well, I know that the empty set is a subset of all sets. And I know that every set is a subset of itself. And so there we go. There are no other possible sets. Okay? Set B. Well, I have the empty set, and I could have the set of J. I could have the set of F, Fran, and then I could have the set JF for Jim and Fran, right? So I did the empty set, then I did all the subsets with one element, and then I did all the subsets with two elements. And then since there were only two elements to begin with, I'm done, right? I wouldn't put down FJ because that would be the same as JF. All right, so let's see here. For C, I have three elements. So I'm going to start with the empty set, and then I'm going to do all the sets with only one element. So there's J. Okay, there's F. And there's B for Betty. Now that I've done all the ones with one element, I'm going to do all the subsets with two elements. So I'm going to do JF. J and F. All right. Then I'm going to do J and B because I'm trying to do it systematic. Now I've used Jim in every subset that has two elements. I won't use Jim anymore. And now I'm going to use F and then B, Fran and Betty. Okay, I've done all possible subsets with two elements. Finally, I need the subset with three elements, which is the set itself. And remember, every set is a subset of itself. And here I have 8 elements. Okay, I would love for you to list out all the subsets of this set, Jim, Fran, Betty, Charlie. Go ahead and pause the video and do that. It's going to take you a minute or two. Okay, here's what you should have gotten. Please, if you haven't done it yet, pause the video and do it. Do it right in your notebook. You're going to get the empty set. And then I'm going to do all the subsets with one element. And so there should be 4 of them, right? Jim, a Fran, a Betty, and then a Charlie. Okay. Then I'm going to do all the ones with 2 elements. And again, I'm going to be very systematic. I'm going to do Jim, Fran. And then I'm going to do Jim, Betty. And then I'm going to do Jim, Charlie. That's all the subsets with 2 elements that use Jim. So now I'll move away from Jim. I won't use Jim anymore. And I'll use Fran, Betty. And I will use Fran, Charlie. Now, that's all the subsets that can use Fran. And so I will move on to the subset of Betty and Charlie. And now, because I've been so systematic, I've done all the subsets with 2 elements. So now I'll do the ones with 3. Yeah, there's a lot here. Okay, so I'm going to have a JFB. And then I'm going to have a JFC. Okay, and then I'm going to have a JBC. I believe I've used Jim up. I don't think there's any other way I can mix Jim into a subset with 3 elements. So I'll move on to Fran. And I'll have Fran, Betty, and Charlie. And so I think that should be it. Let me see how many I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is good because I know there's supposed to be 16 subsets. How do I know? Well, I've got to do the subset with 4 elements, JF, BC, And there we go. There are no other possible subsets. Okay? So if we go back and look, when there was one element, we got two subsets. When there were two elements, we got four subsets. I'm just abbreviating there. Okay, when there were three elements, we got 8 subsets. And then when there were 4 elements, we got 16 subsets. Okay, well, I'm going to go to an input-output table and see if I can't make some sense of this. This, again, this should be a review. Okay, so see the number of elements and number of subsets. All right. And we'll make my little input-output table like this. Yeah, that'll work. All right, and so I've got one subset, one element, 2 elements, 3 elements, 4 elements. I need n elements, right? And I had 2 subsets, 4 subsets, 8 subsets, and 16 subsets. Now, do you notice that they're doubling every time, right? They're not plus 2, it's times 2. This is a special pattern. We haven't talked about this name yet. I will drop the name here. It's an exponential pattern. But for right now, I want to think about 4 in a different way. I've got to think about 4 lots of different ways. I'm going to think about 4 as 2 to the second power. Because if I do that, I can think about 8 as 2 to the third power. Again, this is review. So 2 to the first power, and then 16 would be the same as 2 to the fourth power. And you notice when there was one element, it was 2 to the first. When there's 2 elements, 2 to the second. 3 elements, 2 to the third. 4 elements, 2 to the fourth. 5 elements, 2 to the fifth. N elements, 2 to the nth power. That's my formula. That's going to tell me how many subsets there are. So if I have a universal set, and it has the numbers 1, 2, 3, 4, 5, 6, and 7, and I want to know how many subsets there are, I'm going to do 2 to the 7th power. Well, let's see here. Let's figure that out. That shouldn't be too hard. So 2 to the first is 2, and then 4, and then 8. I mean, 2 to the third, right? And then 16, and then 2 to the fifth is 32. 2 to the sixth is 64, and 2 to the seventh would be 128. And there you go. So 2 to the 7th. So there would be 128 subsets. If I wanted to list them all out, I'm not going to, but I would start with the empty set, right? And then I would do all the sets with one element. And there would be 1, and then 2, right? All the way up to 7. So there'd be 7 total sets with one element. And then I would have to do the sets with 2 elements. And I'd have to do like 1, 2, 1, 3, all the way up to 1, 7. Then I could move on to 2, 3, 2, 4, 2, 5, up to 2, 7. And continue on. And I go to 3 elements, 4 elements, 5 elements, 6 elements, 7 elements. And when I was done, there would be 128 subsets. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.